This is question 3 from tutorial 1 from Learning Outcome 2, page 14 on the course notes. We've got a question. We've been given a car that's travelling, it's accelerating during this journey, and we've been given some information about it and asked to find out some other information. We'll start by writing down what we know. We know the initial velocity is 48 kilometers per hour. Now the final velocity is 112 kilometers per hour. And we know the distance it has travelled is 2 kilometers. Now before we get into our question, we want to convert all of these into the units we'll be using throughout, meters per second for the velocities and meters for the distance. If we start off with our distance, well, 2 kilometers, we can probably quite easily see that's 2,000 meters. 1 kilometer is 1,000 meters. For our speeds in kilometers per hour, we know quick ways to divide by 3.6, and that will give us the velocity meters per second. But just a reminder of why we're doing that, to convert kilometers to meters, we're dividing multiplying by 1,000 and dividing by 1, because that's the ratio of meters to kilometers. 1,000 meters is 1 kilometer. And to get from per hour to per second, well, we need to multiply by the ratio between our hours and seconds, and 1 hour is 3,600 seconds, because we want to have seconds at the bottom of our new units. And we multiply that through, we get 13.333 meters per second. That's the 3 decimal places. So multiplying by 1,000 and dividing by 3,600 is the same thing as dividing by 3.6 to begin with. It's the same conversion factor for our value for V, so I won't write all of that out again, but we're doing exactly the same thing. We're dividing by 3.6, and that gives us a value of 31.111 meters per second to 3 decimal places. Now we can look at part A. We want to find the time taken to accelerate. This is where we'd look at our 4 linear equations of motion. We'd work out which of these has u, v, and s in it, and also t, the thing we wanted to find. And we conclude only one of these equations is going to work here. It's going to be s is equal to u plus v divided by 2 times t. All of the other 3 equations have acceleration in them, and they don't have one of the things that we do have or are seeking to find. So we can take the numbers we've been given from the question and put them into our calculation. I'm going to put them in here, substituting each of them. So u is 13.333 and v is 31.111. That's all divided by 2 and multiplied by t. T remains as a letter because we still don't know what that is, as we're trying to find. In the next line, we can add the 2 numbers in our brackets to get 44.444 divided by 2 times t. And hopefully you can see it's quite quick to divide that. All those 4s become 2s when we divide by 2. And then lastly, we find t by taking our 2,000 and dividing both sides by 22.222 to leave us with t on one side and our division on the other, which leaves us with 90.0 seconds to 1 decimal place. So that's part A. Draw a line to separate it all off. Let's look at part B now, so a different part of my page here. In part B, we're asked to find the acceleration. I should have put this at the top, say T is the unknown. Well, here A is the unknown. And we actually now know U, V, and S, which we were given, and we know T, which we've just worked out. So we can actually use any of our other 3 equations to find this information because they all have acceleration in them and we know everything else. But I'm going to play it safe and use the equation that doesn't rely on the value we've just worked out. So I'm going to do the v equals u squared plus 2as. And I'll put in our values that we have from the question. V is 31.111, that's all squared. I'll put brackets around to remind us of that. We have u equal to 13.333. Again, that's all squared. And we'll add to that 2 times a, which we don't know, times 2,000, which is our displacement from the question. Now, I could choose to just use all, keep these terms as squared and just move them over to one side and put it all through the calculator, but I'm going to break it down into stages, and as such I'll have to do a little bit of rounding, which can sacrifice a little bit of accuracy in our answer sometimes, but if we keep things to 3 decimal places, it should be okay. So we're left with 967.894, that's 31.111 squared to 3 decimal places. And if we do the same for 13.333, and we square that to 3 decimal places, that's 177.769. If we tidy up what we've got after a plus sign, 2 times 2000 times a, we've got 4000 a. So this means that 4000 a is going to be equal to the other two numbers subtracted, so our 967.894 minus 177.769. And that leaves us with 790.125. So to find a, we just have to divide through by 4000, so 790.125 divided by 4000, and that gives us an answer of 0.198 meters per second squared, or meters per second per second. So that's our acceleration. We've found that, and that's part B of the question concluded. So finally, we were moved on to ask to look at part C, and we might not really be sure what we're being asked here in part C, to find the average speed. That's not one of our 4 formula, but actually it's simpler than that. I'll just draw a line across here. The average speed in any question where we have constant acceleration is the initial velocity plus the final velocity divided by 2. Sometimes you might see average speed written as the v with the bar over it. We don't tend to use it in this course, so I'm just going to write out the words average speed to avoid confusion. So average speed is equal to u plus v divided by 2, which is 13.333 plus 31.111 divided by 2. And we actually worked this out already. We go back up here, we saw that was going to be 44.444, and we divided that by 2. It was going to be 22.222 meters per second. And I'd give the answer maybe as to 1 decimal place in a final answer. Now, if you're following along and looking at this in the course notes, you'll see that the answer is given in kilometers per hour. But if we do our conversion, if we multiply by 3.6, you'll see that this does actually work out to be 80 kilometers per hour as well. So that's how you can always check when the answer is given in different units. Just do the conversion back and you'll find out that is indeed the case. So that's parts A, B, and C, and we've answered question 3.